Would you ask Professor Bisby to come back in, please? All right, Professor Bisby.
Yes, thank you.
On we go then. Thank you very much. Yes, Mr. Millett.
Thank you, Mr. Chairman. Professor, we were talking about Class 0 earlier as an external wall classification, given its internal room or corridor reference scenario before the break. And afterwards, or later, we will come on to the differences between the national and the European classification systems and the underlying tests that underpin them. But on this particular point, you have an observation. Can we go, please, to page 174 in your report? Page 174, paragraph 957, at the top of your screen, and you say this: however, the modernisation brought by the new European classification system, having been developed based on a reference scenario that was only loosely applicable to external fire spread hazards, was inadequate to address these more fundamental concerns. The reason for this emerges from Messerschmitt's 2008 analysis of the European system, that the European methods for classifying products were almost entirely based on an assessment of the likelihood of a fire's growth to flash over inside a compartment. And then you have 958, which I read to you before. Now, what do you mean by loosely applicable in paragraph 957 there?
I mean that, the products are installed on a surface and there's a fire involved. It is a test that does assess the way the products react to a fire and the extent to which they'll burn. So it's not entirely remote, if you like. The products are being subjected to a fire. It's that simple, really.
Right. I mean, that's no more than saying that it's a fire test.
Absolutely.
Right,
yes.
I see. Now, can I then turn to technological proof tests, which is the third category of tests that you've described in your report? And I think you would include in that the BS8414 series, would you?
Yes.
Yes. And is it right that the test apparatus and the method are designed to imitate as closely as practicable a real-world use scenario?
That's my understanding, yep.
Yes. And you characterise those tests. If we go to page 44, please, paragraph 216. And I'm summarising here, really, but you characterise them as used when there's little scientific understanding of how various materials or products might behave on a real building. Yes?
That's right, yeah.
Is it right that we should understand that in the absence of such an understanding, the closeness of the resemblance of the test rig to a real-life building is important in allowing designers to make judgments about how a particular system would behave in the event of a real fire in that building?
In my view, yes.
Yes. Are there any other factors in play?
With respect to what?
With respect to the resemblance between the test rig and the real-life building. In other words, not just subjective judgments, but other things too.
I'm not sure I follow the question.
All right. Well, let's see how we go with the next paragraph. Can we go to page 222 of your report? Sorry, paragraph. Yes. Sorry, page 45. My fault. Start again. Paragraph 222 on page 45. And you say there, technological proof tests are different. They rely almost entirely on similarity judgments made by the end users about each specific system. The implicit, and in the case of BR135, explicit, onus of responsibility falls almost entirely on the end user to make a judgment about whether any particular testing outcome is applicable to any particular real-world situation. Can you expand on that, and in particular in relation to BS8414? And in particular, why do they place reliance on the end user in the way you've described?
Because the outcome of a technological proof test, or the observations that would arise if you conduct a technological proof test, are going to be... The reason you're doing the technological proof test is because of the complexity of the system
Yes.
that's in play. And that complexity also means that small changes in the system could lead to differing outcomes. And so if you perform a technological proof test and you observe an outcome, the extent to which the same outcome would be observed if that external wall arrangement, to use sort of the terminology of the inquiry, would manifest on a building in the case of an actual fire is something that you have to think very hard about. And that, I think that's why there are some statements in BR 135 that kind of draw that out, and they warn users quite specifically that this test is only applicable to what you've tested, and if you're going to take this result and you're going to apply it on an actual building out there in the world, you need to make some assessment, make some judgment as to whether or not the result that you get in the BR 135 assessment is going to lead to what you consider to be adequate fire safety outcomes in the real world.
And we'll come back to that very topic later. If we go to paragraph 226 at the foot of page 45, you say this. The technological proof test, i.e. BS 8414, was invoked within Approved Document B and BR 135 in accordance with the logic identified above. It was made explicit that the onus was on the user to ensure that a test result was applicable to any particular situation. However, as has been demonstrated in the evidence to the inquiry, the manner in which it was actually used in practice was more as a non-representative or model test where little thought appears to have been given about the extent to which the tested system was genuinely relevant to the end-use situation. Now, is it right, in other words, that in your view, Approved Document B and BR 135 made it clear that the user of the test had to ensure that a particular test result was applicable to a particular building situation?
Certainly BR 135, yes. And I think Approved Document B kind of in an overarching way, given its legal status as guidance rather than the law.
Well, that's the next question. How, in your opinion, did ADB itself do so, even implicitly?
ADB, there are statements both within the building regulations and within ADB that there's no requirement for a user to meet the requirements of or to meet the recommendations, to adhere to the recommendations of Approved Document B, and that designers can do things whatever the way they want. The Building Act itself basically says that if one, and prior editions of ADB basically have said that if one wants to do that, that is fine, but in the event that something goes wrong and you're found not to have followed the rules, then you're on your own. If you have followed the rules, then there is a tending to negative liability associated with those actions. So there's some kind of comfort in following the rules of ADB, but it is not an absolute defense of behavior, if you like, or of design decisions, if that makes sense. Mm. So the approved documents don't require you to do anything, and like by virtue of that, I don't see that they can be used as a bulletproof defense of actions. You might follow the recommendations of the approved document and still end up with a system that does not adhere or does not adequately resist the spread of fire on the outside of a building. Now, it's conceivable that could happen.
In that last answer, you used the words rules at least twice.
I probably misspoke then.
Well, I was going to see if I could understand why you misspoke.
Sure.
Why did you refer to them as rules?
You'd have to show me the transcript to see where I did it in order for me to...
I can read it back to you. I'm just interested in what lies underneath this. You say that in prior editions of ADB, basically, if one wants to do that, it's fine, but in the event something goes wrong and you're found not to have followed the rules, then you're on your own. If you have followed the rules, there's a tending to negative liability associated with those actions.
Yeah.
And I just wonder whether when you use the word rules, even you, Professor, might be indicating some kind of underlying tacit understanding of how ADB was supposed to work.
I mean, it's possible. I'm not in the position of ever having used ADB in my practice, so I can't tell you how I would have thought about Approved Document B prior to the Grenfell Tower fire. But I have always known, or at least to the extent that I've ever thought about it, that the building regulation system in the United Kingdom was functionally based, and that the consequence of the Building Act was that designers are free to do whatever they want, if you like, provided they can meet the requirements that are stated in the building regulations. And that, I suppose, in practice, provided that one can get the necessary approvals for what one sets out as a designer, one can do those things. If something goes wrong down the road, how one would defend oneself, I think is sort of relevant to that status of the approved documents. But I mean, yeah, it's easy to slip into using the word rules because whilst they are not, I guess, formally, I'm not a lawyer, of course, but whilst they're not formal legal rules, it is not prescriptive deemed to satisfy guidance. They are, if you like, they are effectively written as rules. So yeah. I think that's a misuse of language, for sure. On my part.
But a helpful explanation nonetheless. Thank you. Can I take you then to paragraph 226, which starts at the foot of the previous page, page 45. And you say there, as really halfway through the paragraph, so long, a third of the way through the paragraph, thus, so long as the literal rules of the test standards and approved document B were, quotes, followed, unquotes, in practice the regulatory system appears to have placed no onus whatsoever on the user to ensure that the particular testing framework applied to any specific situation was suitable for that product or for its application on a building. The regulatory influence of this category of tests was much more significant as regards the application of combustible cladding products, in particular the classifications of British National Class 0 and European Class B S3D2, both of which are based entirely on model tests, appear to be profoundly relevant to what occurred at Grenfell Tower and to many other UK buildings with problematic cladding now constituting the UK's cladding crisis. Now, I'm interested in what you say there when you say that. Sorry, then you go on to say, as we've seen already, that the manner in which 8414 was actually used in practice was more as a non-representative or model test. Now, taking those two paragraphs together, are you able to tell us what you really mean by 8414 being used more as a model test?
Being used in a way such that if one is able to, not that this language is used, but quote, pass an 8414 test, achieve a classification under BR 135 for an 8414 test, that it is viewed as a result that can be relied upon to give a great deal of confidence that when applied to a building, the outcome in the event of a fire would also be positive, if you see.
And therefore it's treated, but mistreated, is this your view, as a model, really, rather than a representative test, which is what it was designed for?
Yes, yes, that's right. Yes, it's treated as a non-representative test. A pass-fail result is something that I'm willing to call a pass-fail result. A technological proof test is something where I'm not happy to call it a pass-fail result. A model test is somewhere in the middle where there's this discretion. So it's a question of the level of discretion, the onus of responsibility and discretion on the end user, with an increasing level of onus of responsibility on the end user, the user of the test, as you go from non-representative through to model, through to technological proof test. So the technological proof test requires a great deal of responsibility and awareness from the user. And that was not, as far as I can tell, that was not deployed out there in the industry, it seems to me.
I'm going to examine 8414 in a little bit more detail shortly, but before we do, can I just ask you, arising out of the last series of answers, this. Are Class 0 and the European classes that give rise to Class B, both of which are placed within diagram 40. Are those model tests or are they technological proof tests?
They're model tests.
They're model tests?
Yes.
So moving on to the next stage then, we find those, don't we, identified in approved document B at paragraph 12.5, which says you can either follow the linear, what is called the linear route, 12.6 to 12.9, or satisfy the performance criteria derived from tests under BS 8414, yes?
That's right.
Is it your opinion that in expressing satisfaction of the guidance in that way, that the person using approved document B is being presented with two alternatives that are not strictly alternatives? One is a model test, but its alternative is not also a model test. It is a technological proof test.
Yeah, no, it's a very good insight. Yes, I think that's true.
And
I think that type of language could create the false impression within the user community of ADB that there is an equivalence of, let's say, approach in terms of how one uses those two routes, let's call them. I think that's probably a fair, yeah. I've not thought of it that way. It's a good insight, yeah.
Let's move on to BS 8414 then. And at a later stage, we'll look at the performance criteria. Can we go to page 42 of your report, please, and paragraphs 210 to 211? And you say there, what emerges from this specific framing of the technological proof test is a realization that to criticize the BS 8414 test for being unrealistic is to reveal the critic's fundamental misunderstanding of the nature and purpose of testing. It should be obvious that BS 8414 tests can never be faithful reproductions of anything other than BS 8414 tests. In other words, the test is the test. It is what competent professionals do with the test results that is most deserving of scrutiny. Now, for completeness, at the end of paragraph 5 of your report on page 2, if we skip back to that, please, page 2, paragraph 5, it's the same point. You say there, at the end of paragraph 5, fundamentally, I aim to demonstrate that it is usually unfair to criticize a test for being too small, too unrealistic, too variable. A test is just a test. It is what people choose to do with the results from a test that matters. Now, in that description, in both those paragraphs, when you refer to people, who are you referring to?
I'm referring to the people who are making design decisions.
And what about the people who are creating the regulatory regime in the first place? Do you include them as well?
Those, and I've discussed this somewhere in the report, I can't remember where exactly. Those people do have a responsibility in terms of both articulating clearly for the users all of these embedded assumptions and intents that sit behind the test methods, and in setting the let's say the pass criteria, or setting the bars that need to be met in a way that that is credible given what the test is doing for you, right? So and I set this out in the report. So the unrepresentative tests, so if you were to say I'm only going to allow A2 products, and I'm going to do bomb calorimeter tests, which are non-representative tests, and I'm going to pick a very, very low heat of combustion as my criteria that I can use, well, then I'm pretty confident that the user of that result doesn't really need to know how a bomb calorimeter works, doesn't really need to know much about what bomb calorimetry is, but needs to understand a little bit about heat of combustion. But if they adhere to the less than 2 megajoules per kilogram or whatever it is, then probably your outcomes are going to be not so bad, right? Because it's a conservative test and is not representative. But at the other end of the spectrum, when you have BS 8414 test, I mean, understanding exactly how adequacy is defined in those tests is a bit of a challenge, as I'm sure we'll come to. But but you could have much less confidence that the outcome of that test will lead to a satisfactory outcome, because it is less conservative and more complex and more fraught with challenges and more difficult to take from the lab out there into the real world. So that's kind of what I'm alluding to here. But yes, no, you're right. There are responsibilities and expectations that we must place both on those people who use the tests and on those people who set those tests out for use by others. I think absolutely, yeah.
Yes.
And I think maybe that latter point probably doesn't come through as strongly as it ought to, reading this back now. Yeah.
Now, building on that, can we then go to page 13, please, paragraph 54? And this covers the point that we've seen already, but you explain here that the key issue is not whether a test is realistic, but whether it's sufficiently representative. And you go on to quote from Downer, and I've read that to you already. This is footnote 8 in paragraph 54. I'll read it again. Halfway through the paragraph, since even the most realistic tests will always differ in some respects from the real thing, engineers must determine which differences are significant and which are trivial if they are to know that a test is relevant or representative. Now, looking at the engineer who is to make this determination that you describe, who is this person? What is their minimum level of academic qualification that they need to have reliably to be able to consider the design of a test which you would expect to be adequate when testing a cladding system?
Are you asking me who it is in practice in England, or are you asking me who I think it is, who I think it ought to be?
Well, the latter.
I mean, not for me to say, I don't think. I'm just an academic engineer who works at the University of Edinburgh, who has opinions about the levels of competence that people ought to have. There ought to be some, in my view, some mechanism by which society, all of us, can have some confidence that the people who we are going to charge with making those assessments and decisions as we move from the lab to the real world know what they're doing, have some fundamental technical understanding, have some moral and ethical standards that they're operating with, have some uncertainty about the things that they know, and are willing to be thoughtful about that uncertainty, to demonstrate competence and an awareness of their own incompetencies. And how one, I mean, this is, in a way, the issue of everything I've done with respect to this inquiry. How do we as a society ensure that the people that we charge in making these decisions have the relevant competencies? How do we define them? How do we assess them? How do we police them? And what do we do when people don't display them or have them? What measures do we put in place to make sure what measures do we put in place to make sure that society can have that confidence? If we're going to have a functionally based building regulation system that permits anyone to do anything, what do we do to make sure that that doesn't go horribly wrong? And that is a very fundamental question. But I can't sit here and tell you the only people who should be doing this should be people that have this degree in this subject area, they've passed these examinations, they undergo this amount of annual CPD training as recorded by some regulatory authority. But the idea that we should regulate and register the people who are making these decisions is very fundamental to my views now. I'm not sure if that's a long-winded and slightly peripheral answer to your question.
It's certainly an answer to the question as interpreted, as I put to you, the latter, but try the former. Who are the people now? And looking at the body of available expertise out there, as at June 2017, were those qualifications defined or assessed or policed in a way which you, in your opinion, consider satisfactory or satisfactorily safe?
No, what controls are there? There are effectively no controls over who can claim to make that assessment. The only control is the only control that seems to exist in practice is the tolerance of the approving authority, whoever they are, and therefore the competence also of the approving authority, which is also not very well controlled, as far as I can tell.
When you say approving authority, do I take it you mean building control officers?
Yeah, I mean, typically if we're talking about doing something to a building, building a building, or doing something to it, to the extent that what's being done requires building control approval, then yes.
Now, let's go to page 41 of your report, please, paragraph 203. You say there, and you've covered mock-ups and the representative nature of the 8414 test itself. You say at paragraph 203, more challenging, however, are the relatively inflexible parameters that are defined within the testing standard itself. Although BS 8414 has intentionally been made to be more, quotes, representative, some compromises to reproducibility appear to have been necessary in its design. For example, the BS 8414 testing apparatus does not include any windows. It could, of course, but the window openings in a real building might be situated differently to those in any BS 8414 test arrangement. Would it be necessary to retest for every possible window size, type and shape, or every possible window frame material? What if the windows in the real building are open at the time of the fire? How open are they? What if they are open in tilt versus turn mode? The list of potentially influencing parameters has literally no end. Now, in light of that litany of variables, do you consider that the BS 8414 test rig as required and the example test rig shown at A1 of the third edition of BR135, which we can look at if we need to, should have been designed as it was, in other words, omitting all windows or apertures?
Do I consider that it should have been designed that way?
Yes. Was it an appropriate design, given that it is a rig which has no apertures or windows at all?
Depends what you want to do with the result. I mean, yes, sure, yeah. I mean, I can't criticize BS 8414 for all of the reasons that I've mentioned there. And as you know, as I've said before, the test is the test. We can criticize it for being unrealistic, and we can say, well, I want to use the result of an 8414 test in a building that has windows, and those windows are this size and shape, and they're directly one above each other, and this is the story height, and I build a rig and I test it. But if you go down that path quite quickly, you realize that every time you want to build a building, you have to build it and burn it down. And that's not going to work out there in the world. And so we have to make compromises. But when we make those compromises, we have to be clear about what those compromises are, and we have to be clear about the extent to which we're going to demand that the people who take the result then understand those compromises and account for them when they go off into the real world. So I think no. I mean, to take the window example as an example, so let's say I decide, well, okay, that's unrealistic and I want to have windows in my test rig, so I put some windows in my test rig. Well, you know, what kind of glass do I put in? Do I put single glazing? Do I put double glazing? Do I put toughened glass? Do I put, as is common in buildings now, do I put reflective films on the outside of the glazing to help me with building energy performance that might impact on the radiative properties of the glass? You know, all of these questions, and it's important to recognize that if I'm interested in evaluating the fire performance of, let's say, a cladding system that might incorporate combustible products, either insulation or rain screen, and I displace some of those products by inserting windows into my rig, maybe I've actually made it more likely that I'll pass by inserting windows and not less, because I've displaced fuel that would otherwise be there and burn. And so, you know, as soon as you start tinkering with a test like this, the potential for tinkering in a direction that is not what you hoped, or, you know, more worryingly, the potential for tinkering by people who might seek to tinker to their advantage, is immense. And so BS 8414, whilst being unrealistic in many respects, and as I've said, it can only be truly representative of a BS 8414 test. So unless my building is literally an 8414 test rig, then I have to ask the question, how might my building, how might this system, this overall buildup of products on my building, given that the joints are going to be in different places, the windows are going to be in different places, the cavity barriers are going to be in different places, the fixings might be different, maybe I have a wing wall, maybe I don't. All of those questions, you have to, and this is why I say, you can't just take a BR135 classification, point at it and say everything's fine. You have to think about how this is going to be applied to your building. And that, I think BR135 is very clear about that. It says this is the classification based on a BS 8414 rig, not on a building. And if you're going to put it on a building, you better think about it. Now, granted, it doesn't give you a huge amount of help in terms of how one would do that, but that's why the people who are doing this type of work need to be competent if we're to have any faith in the outcomes.
Can we just look at BR135 then, please? BRE 405555. And I'd like, well, let's have a look at the first page, please, first of all. And the second page is the one which tells you that this is the third edition. And if we go in it, please, to page 26. We can see the rig design there. And you can see in it, under test method, that's an example of a test facility and the principle of the test. And then if you go, please, to page 28, there is the warning. Page 28, please. Yes. Under the 3 bullet points, it says, the classification applies only to the system as tested and detailed in the classification report. The classification report can only cover the details of the system as tested. It cannot state what is not covered. When specifying or checking a system, it is important to check that the classification documents cover the end-use application. Now, is that what you're referring to when you say in your last answer that you need to think about it?
Yeah.
In fact, when it says it cannot state what is not covered, would it be right for an engineer reading that to understand that actually what is covered is pretty limited, given all the other variables you've referred to, the geometry, the fixing joints, the apertures, the windows, matters of that nature, so that actually the test rig as tested and covered by the classification report is some way away from the end-use application, even if the materials and the geometry of the use of the materials in relation to each other is the same.
Yes, I mean, that's certainly how I read it, and I've always read it to the extent that I've looked at it. I mean, I've had to accept that my reading of things appears kind of atypical in this community, but that's certainly how I've always read it, yes.
So what's the, forgive the simplicity of this question, or perhaps the bluntness of this question, but what's the point of BS 8414 as a test, as a system test, if it is unrepresentative of the end-use building to such a degree? What help does it? It's a test is a test, but what does it actually tell you?
It can tell you what is. It can tell you what would be a really bad idea. Is what it can tell you.
Right.
And it can't tell you much more than that.
Right.
Sorry, before we go on, can I just check with you? This paragraph here that you've just been asked to look at is the only paragraph that you are aware of, is it, which tells the end user, or the user of the test, that he's actually got to think about the results he's got from the test and how they apply to his building, not just to accept a pass as a pass in as if it were a model.
I think I would want to check the rest of the document before saying definitively, but I think, yes, I think this is probably the only place where it would be stated explicitly and it's not even that explicit here, if we're being honest with ourselves, is that it's stated here, certainly intimated. I think as I say, I have always read it that way, but I have had to realize I'm a bit unusual. Yeah. I do think that, as I've said, I think that if one understands one's role as a designer within the broader regulatory system, and one considers the building regulations, the Building Act, that one should recognize one's professional responsibility, regardless of what BR 135 says. Even if BR 135 was completely and utterly absent, there would still, in my view, any competent professional should understand that they just cannot blindly follow rules or recommendations and hope that that them dispensing reasonable skill and care. I mean, we just cannot accept that from the engineering community. And that, I would refuse to accept a view that competent professionals practicing engineering in safety critical areas should be permitted to say, oh, well, the document never told me so. I just can't. I can't accept that.
It sounds to me, from what you've just been saying, that you would feel more comfortable if the warning, which I think you're saying it really is intended to contain, were much more explicit.
It would certainly be helpful if it were much more explicit, and it may well have prevented some of the sort of the misconception around the use of this document, or the application of this document, I think.
But would it also follow, in your view, that it may or may not be appropriate for ADB to advise people that they can satisfy the building regulations by getting a pass under BR 135?
If that's how one reads ADB, yes.
Yeah.
Yeah.
All right. Yes. Thank you very much.
It would have been helpful if clause 12.5 said, although, I think, as I said before the break, I'm not sure ADB is obliged to say this, but given what we have observed about the behavior of people within the industry, perhaps it would have been helpful for ADB to say in a number of places, just to remind you, everyone, even if you follow the rules in this document, that's still not you home free, so to speak. You still have to think about, not rules, apologies, Mr. Miller, recommendations of approved document B. Even if you follow these rules that are set out, these recommendations that are set out in approved document B, it's still on you as the competent professional, as the designer. And I think that the more people out there in the world can be reminded of that, and to the greater extent that people out there in the real world can be held responsible for design decisions that they've made, all the better.
So do I take it from that series of answers to the chairman that actually the putative competent fire safety engineer or a competent fire strategy relying on this document would not need to have this spelt out to him, even if it is a spelling out? They would know it intrinsically.
My view is that they ought to, yes.
They ought to. And were you aware that this paragraph was added to Appendix A at the same time as Appendix B was introduced in this third edition in 2013 and had been absent from the second edition, which only contained Annex A, in very much similar form in 2003? Did you know that?
Possibly. I mean, as you're telling me, I'm thinking, oh, that's interesting. I'd want to go back and look.
Okay. Yeah. Let's just move on then with the question of windows. First of all, are you able to offer us a view in simple terms which will tell you more about the potential for external fire spread? A rig with window gaps or a rig without?
I mean, it might tell you different things.
Right.
Yeah.
Let's go to figure 2, please, page 11 of this document, which is BRE 135, third edition. Here's a photograph under figure 2 of Garnet Court, Irvine, and you can see the fire damage from the windows directly in line of the vertical fire spread. Mm-hmm. Yes, and if we go down to page 13, figure 3 is the graphic representation of a fire scenario with fire climbing the building and re-entering the building via windows, you see? Mm-hmm. Under mechanisms of fire spread, it says the key stages associated with fire spread on the outside of a building envelope are, and then they're in order: initiation of the fire event, fire breakout, interaction with external envelope, and then across the column, fire re-entry, fire service intervention. These stages are discussed below and are illustrated schematically in Figure 3. And you can see the process there. The secondary fires entering through the windows on each floor, or through apertures at least, on each floor. Now that's dealing then, isn't it, with re-entry of fire into the building through windows? Yes, that's the assumption here, as it travels vertically. Now, given that BR 135 is overtly directed at the hazard posed by cladding fires and re-entry, is it right to say that some compromises to reproducibility appear to have been necessary in its design? My question is this not a pretty major compromise, where the rig itself doesn't have any windows to let fire back in?
Okay. My understanding of what BS 8414 and BR 135 testing is trying to tell you, us, them, whoever's using it, is whether or not, or perhaps the extent to which, a combination of cladding products on the outside of a building is likely to contribute to the upward progression of fire. It's not a test that is trying to tell you necessarily whether or not that contribution to the upward progression of fire is going to go in a window. I think the assumption is that if the cladding system contributes to the upward progression of fire, that is going to make it more likely that more windows will become compromised.
Right, all right.
If that makes sense.
Yes, it does. I see. But, in what way does the 8414 test series actually test for the risk actually depicted here in Figure 3, given those 5 key mechanisms, stages?
Only insofar as one assumes that if you have a fire spreading up the outside of a building and it finds a window, then it's likely to enter that window.
Right. So is it right that, in your understanding, BR 135 appears to consider a specific risk which the associated test, BS 8414, doesn't in fact seek to address, namely fire re-entry?
I mean, yeah, it doesn't address it explicitly in that it doesn't reproduce that, but the problem is that in order to address it explicitly, you would end up with a litany of further questions about the particular characteristics of the windows, which would become an impossibility. Even if you said, okay, well, we're not even going to have glass there, we're just going to have a big void, then, what are you going to put inside the void to check whether ignition occurs? Do you have curtains? And if you have curtains, what are they made of? And do you have a sofa? And, it just goes on and on. So I'm perfectly happy to sort of be critical of the BS 8414 test in terms of how it's used and various other aspects of it. But to criticize it for not having windows, I just don't think makes any sense.
And you've given the reasons for that. My question is slightly different, though. I mean, is there not a mismatch between the mechanisms of fire spread addressed in BR 135 on the one hand, which does address fire re-entry, or at least the key stages of fire spread externally involving fire re-entry on the one hand, but the BS 8414 test not doing so?
I take the point. I think that if I were to try to argue on behalf of BR 135, I'm not quite sure why I'm doing that, but if I were to try to argue on behalf of BR 135, I would probably say that if the cladding system is seen to result in upward progression of the fire, 5 meters above the hearth, then that is giving you an indication that there's a larger potential that you're going to get break into a window above the fire of origin, if you like.
Yeah.
So it's indirectly addressing the question in a way.
Does I see? I mean, I don't want to put words in your mouth, but does it come to this, that the mechanisms for fire spread addressed by BR 135, which is not just a list of criteria, it has some background to it as well, which includes fire re-entry through windows, include, but not exclusively include, the mechanism for interaction with external envelope.
Sorry, you'll have to ask me that question.
Yeah, let me try that one again. Is it in fact is the right way of reading these two tests, these two elements together, BS 8414, the test, and BR 135, the criteria document on the other, that the criteria document goes further than the test, because BS 8414 tells you only about interaction with the external envelope. It doesn't tell you anything about fire re-entry.
I think that a classification of a system to BR 135, after having performed a test on that system to BS 8414, equally doesn't go any further than what the 8414 test is telling you. I'm not sure I'm not sure I either understand nor I'm answering the question, Mr. Miller.
Let me try this the other way around. If you met the performance criteria on the basis of test data derived from BS 8414 parts 1 and 2, would that eliminate the risk of fire re-entry?
If you were to meet the criteria?
Yes.
No. No, it wouldn't.
Why not?
Because your real building has windows, probably.
Yes. And what is there in either the BS 8414 rig design or BR 135 to tell the designer that?
Explicitly? Nothing. Just from memory, nothing.
Let's talk about 1919 and the path to Grenfell. And I want to pick up from part 2 of your report. You've given us a detailed overview of the evolution of the building and testing landscape and the regulatory regimes in place from 1919 onwards. We land, I think, in the mid-1980s at page 90, if we can pick that up. And at page 90, paragraph 442, you tell us, oops, that is not the right report, I don't think. No, we need, I think, to go, please, to your Path to Grenfell report, which is LBYP 2 701. And in that document, we need page 90. Thank you. Paragraph 442. And you say this. There had therefore been a fundamental shift in the way designers could practice. In principle, there were no prescribed constraints on how the adequacy of the proposed design could be demonstrated against the requirements of the building regulations 1985. There had not, however, been any fundamental changes in the testing standards which underpinned the approved documents. Indeed, to maintain continuity with the past, it was logical to retain the majority of the existing testing methods and performance standards, even if these were no longer mandatory, or if the new test methods or classifications were available to supersede pre-existing ones. And you then go on at 443. The idea of linking a performance standard and a test method had been enshrined in law since the 1950s. It was necessary to continually review the tests and the performance standards to ensure that they were fit for purpose, to check that they had not been invalidated by a new material, product, or system. This had been the fundamental objection of RIBA and the FRS to mandatory performance standards in 1958, that such mandatory standards constrained innovation Breaking this link was expected to allow unconstrained, quotes, flexibility. Now, that's the background to what I now want to show you, which is 444. And you say this: since the performance standards and tests were no longer seen as constraints, the need to continually review and update became less urgent. If a new and innovative product failed to meet the stated performance standard, then the product manufacturer could simply find alternative means, quotes unquotes, by which to, quotes, demonstrate safety, close quotes. In this new functionally based model of building regulations, devising ways to circumvent the prescribed guidance of the approved documents was not finding loopholes, it was the intent of the regulatory system. Now, I just want to focus on the last part of that paragraph there. Why do you say that finding ways to circumvent the statutory guidance was the intent of the system?
Because the point of a functionally based regulatory system is to promote innovation and flexibility. One of the points is to promote innovation and flexibility. And so, provided you can demonstrate, in quotes, that your product or system meets the functional requirement, then you don't need to follow any particular performance standard or test method. It's up to you to meet the requirement, the functional standard, whatever way you choose. So that removal of deemed to satisfy routes, let's say, to compliance with the building regulations was quite explicitly the point of these changes to the regulatory procedures. To remove these constraints that were it's quite difficult to update a test standard and change things as a consequence of new products and things. So if you want to promote innovation and flexibility in the interests of industry, then it does make sense to allow people to do what they like.
So are you saying that instead of having a prescribed system where people would look for loopholes with which to circumvent, you created a new open textured flexible system where you no longer needed to do that?
Yeah, I mean, you could argue that the system was created specifically to enable people to circumvent the rules.
And how could they demonstrate safety other than by reference to adherence to a classification system based firmly on reliable tests and reliably applicable outcomes?
In practice?
In practice.
They would make some justification. They would write that up as their design, and they would seek the approval of the approving authority. And if the approving authority said that they were satisfied, then I guess you would build it.
And at what point would you know, within a reasonable degree of certainty, whether or not you had met the functional requirement?
In practical terms,
yeah.
With respect to fire safety,
yes.
If you had a big fire and everything went horribly wrong.
Right. So while that happened, you'd be taken to have complied until it happened when you suddenly realised that you hadn't.
Mm-hmm.
Now, at page 91, we have Malhotra. You start the quotation in the previous paragraph. In fact, let me show you what Malhotra says at paragraph 446. Actually, I've jumped a little bit ahead too far. Malhotra, then a long-time veteran of the Fire Research Station, summed up the significance of these fundamental changes as follows. Historically, over the last 3 centuries, we've moved from strict constructional specifications to functional or semi-functional requirements with the performance-orientated objectives as and when feasible. Rigid controls are being replaced progressively by a more flexible system which permits alternative solutions to be considered. The burden of responsibility is being shifted from the central or local authorities to the individual or corporate designer stroke contractor for the adequacy of this system or his system. And that's a quotation from Malhotra in 1986. Then you say this at 447. Malhotra concludes, 448, it will be perhaps another 2 or 3 decades before the consequence of this approach can be seen. Now, we can see that Malhotra was only a year or so out in his prediction, yes?
Mm-hmm.
What was it then, do you know or do you think, that Malhotra saw, which people did not see in the intervening 30 years?
I don't know, again, because I wasn't around, and I never met Malhotra, unfortunately. But to me, this quote expresses concern. It expresses a concern that that this shifting to individual corporate designer contractors for adequacy without some appropriate level of oversight has the potential to cause significant problems, but that because we are working in fire safety and because severe fires are thankfully rare, it might take a long time in order for the chinks in the armor, if you like, to manifest. I mean, when I found this quote, I thought, wow. Yeah. Spot on.
Let's move on to some of the missed opportunities that you identify to address key problems relating to the regulation of and industry practices prevailing in testing, design and construction of external wall systems. We start, I think, with Knowsley in 1991, 5th of April, Liverpool, about which we have heard some evidence in the course of Module 6. And let's go, please, to page 95 of your report here, paragraph 470. And you say there, in the early hours of the 5th of April 1991, a fire occurred at Knowsley Heights. On arrival, the fire brigade reported that it was the most frightening thing any of us had ever seen as firefighters, and that flames were coming from every landing window between the ground floor and the roof. That's a quotation from Shannon, 1991. There were no fatalities, and the fire brigade were eventually able to bring the fire under control. And if we go to paragraph 465, you confirm there, page 94, that the rain screen used at Knowsley was a glass fibre reinforced polymer GRP sheeting product with an aggregate finish on its outside face. The product's marketing literature suggested that the polymer used was a polyester polymer resin. The GRP rain screen was a product called Cape Stenny sheeting and was presented as being a Class 0 product. Now, I think you've reviewed the BRE's 1992 investigation report into that fire, written by Penny Morgan and others, yes?
Mm-hmm. Yes.
And for reference purposes, that's at BRE 3035385. I think you've also looked at her witness statement, yes?
Yes.
And that's at BRE 3043866. And at your report at page 95 at paragraph 472, foot of the page, you say this: the investigations concluded that the primary reason for the rapid and widespread progression of the fire had been the complete absence of cavity barriers between the rain screen cladding and the mineral fibre insulation. As a result, the first major revision of approved document B, which was already underway at the time of the fire, increased the degree to which cavity barriers were recommended within rain screen cladding systems. Now, if you go then to page 98 and paragraph 486, you say there, from my perspective, what is most notable about the report of the BRE investigation into the Knowsley Heights fire is the striking absence of any explicit discussion regarding the degree to which the GRP rain screen product may have contributed fuel to the fire. I find this particularly notable since Knowsley represented a highly significant project in the development of rain screen cladding systems. I have found no documentary evidence to suggest that anyone openly asked the question, what was burning within the cladding at the top of the building? It appears that the sole focus regarding the fuel for the fire was on the refuse judged to have initiated the fire at the building's base. I find it surprising and alarming that nobody appears to have taken an explicit and active interest in the combustibility of the Class 0, quotes unquotes, Class 0 GRP rain screen product. At the time of writing, I've seen no such interest evident in the documents made available to me. Now, why is your reaction one of surprise and alarm?
There've been two moments in this inquiry when I've been speechless, and one was when I read that it was GRP cladding at Knowsley Heights, and the reason that I was speechless was because I was aware of Knowsley Heights, have been for many years, and I'd read, BR 135 and various other reports and things over the years, And the problem at Knowsley was the absence of cavity barriers, right? That's what I believed. That's what I was told. Because that's the problem. That's the narrative of Knowsley. The narrative of Knowsley is that there were unobstructed cavities all the way up the building, and that's why there was a big fire. Now, my professional background, I come from a structural engineering background, and the way I got into fire was because I was interested in using GRP materials in structural engineering applications, and they burn quite nicely. So my route into this profession was through understanding the way GRP burns. So when I, for the inquiry, thought, when I was asked to look at the regulatory regime and the testing, I thought, well, right, where do we start? We start at Knowsley. So let's go back and look at Knowsley. And I looked at Knowsley, and as soon as I started reading the documents been provided to me about Knowsley, and I realized that it had been GRP, I thought to myself, with the question here, what was burning 10 stories above the refuse? If this was a non-combustible cladding system and it had no cavity barriers, can I really get flame extension 10 stories up an unobstructed cavity due to fuel only being at the base? And I immediately went and spoke to my colleagues and said, guys, am I crazy? But does it seem pretty unrealistic that you get fire coming off the top of a building due to refuse burning at its base, even if you have an unobstructed cavity? And they agreed with me. So that, the fact that, and then I started to look for mentions of the combustibility of the cladding over decades, and I found none. And then I looked at all of the work that came after Knowsley, and I looked at trying to understand how Class O kind of perpetuates within the system, trying to understand the sort of slightly odd British focus on cavity barriers in these systems that doesn't exist in many other jurisdictions around the world. And it all goes back to Knowsley. And it all goes back to Knowsley in the absence of any significant discussion about the GRP cladding. So I can't remember now what the question is, but to me, that was really, a sit-up straight moment. And I've tried quite hard to understand why. Like, why was it not mentioned?
And have you found an answer?
No.
Now, if we go to page 99, paragraph 496, you say, on the basis of the above summary, it is apparent to me that the BRE investigation into Knowsley Heights failed to fully address the degree to which the presence of a combustible rain screen may have contributed to the spread and magnitude of the fire. Even with the considerable benefit of hindsight, I struggle to understand how this factor could have been overlooked during these investigations. This is particularly the case, given that the rain screen product used at Knowsley Heights was a glass-reinforced polyester composite, which will almost certainly have had some and perhaps significant potential to contribute fuel to an escalating external fire. Are you able, Professor, to offer any possible or plausible scientific basis which could justify or explain the omission of any discussion of the combustibility of the GRP cladding from BRE's work?
Only that those who investigated the fire on behalf of BRE may have not understood themselves that something that is class naught isn't necessarily non-combustible, right? So those who investigated the fire on behalf of the BRE may have been operating under the misapprehension that class naught means won't burn. And if they were, then you can kind of understand. They wouldn't have considered that the rain screen could possibly have contributed if they thought it was non-combustible. Now, they would have been wrong to think that, but nonetheless, they may have thought that. So, Penny Morgan, for instance, may not have realized that class naught and non-combustible are not the same thing.
Well, let's look at her witness statement, which is, I think, one of those things that you read. At BRE 3043866. And if we go, please, to page 21, paragraph 115. She says, and this actually answers a question at the foot of page 20, which we need to look at paragraph 114. If we could just pick that up, I'm sorry. And the question at the foot of 20 is, did you understand the fact that the GRP rain screen cladding applied to the external walls of the Knowsley building had achieved class naught to relate to the combustibility or otherwise of the product? Please explain your answer. And at the top of page 115, she says this: to the best of my recollection, I understood that GRP rain screen cladding had achieved class 0, which did relate to the combustibility of the product. And then if you go to page 22, I'll show you two things. Page 22, paragraph 125, she says, while I cannot recall due to the passage of time, I assume that I did consider the cause of the vertical fire spread to be a matter of significance, as a ground-based fire had spread over what was purported to be non-combustible cladding. Now, what do you make of that evidence?
It would appear that she doesn't understand the distinction between class naught and non-combustible.
Do these passages that I've read you from her statement throw any light on the state of knowledge, assuming her to be representative for the moment, a state of knowledge in fire engineering circles in the early 1990s about the limitations of class naught and the risks of external fire spread presented by products like GRP?
Well, I wasn't there, so I can't really speak to whether or not this view would have been typical. It does seem to me that over the years there has been quite a lot of confounding of these two concepts, yes.
The two concepts being?
Class naught and non-combustible.
And when you say confounding, you mean conflating?
Sorry, conflating, yes.
Well, it's the same thing, but people understand conflate better than confound.
Yeah.
Can we then go to page 99, paragraph 491 of your report, please? Back to your report, your Paths to Grenfell report. Page 99, paragraph 491. You've quoted from the passage I've just read to you, and then you also quote from 490 from a later BRE report, which says this. I'll just read this to you. The most significant of the historic external fires is that of the 1991 fire in Knowsley Heights, a residential block of flats which had been refurbished with the addition of thermal insulation to the external walls of the block. The fire started externally to the block and ignited the combustible cladding system, resulting in extensive fire spread across the face of the building, mostly upwards. And then you say at 491, I agree that the Knowsley Heights fire was the most significant of the historic external fires, which is why the apparent failure to properly interrogate the key issues or make the necessary changes to the relevant guidance is so tragic with hindsight. The above quote also suggests an unarticulated knowledge of this issue within BRE going back for decades. For what reasons do you consider that this fire was the most significant of the historic external fires in the years between 1991 and 2017?
Because of what it ought, because of what it ought to have caused people to think about, but didn't, apparently.
And what interrogation do you think should have been carried out into what you describe as the key issues?
Those who were investigating this fire ought to have tried to understand the extent to which the escalation of the fire vertically was a consequence of the continuous cavity or a consequence of the combustibility of the rain screen, rather than focusing, as far as I can tell, uniquely on the continuous cavity. And you know, I mean, Knowsley Heights is why, as far as I can tell, is why we have such a strong focus on the use of cavity barriers. If after Knowsley, someone had stood up and said, well, actually, a significant proportion of the adverse outcome at Knowsley was because we had a class naught combustible rain screen, then maybe we wouldn't have had many other fires, including Grenfell Tower. You know, I think it's impossible to overstate the importance of what was missed here.
And in paragraph 491, where you say failure to make the necessary changes to the relevant guidance, what are you referring to? What are the necessary changes that should have been made?
A reconsideration of class naught.
Right.
Presumably the GRP panels from Knowsley were removed and examined, were they?
I don't know. I mean, Knowsley was reclad, as far as I'm aware. I certainly don't think and hope that those panels are not on Knowsley Heights still. Although I have to say, given what we've observed, it wouldn't surprise me if they were.
I mean, I ask the question because if they were removed and examined, fire damage to the internal faces would have been apparent, wouldn't it?
Yeah, I mean, there are photos in the fire investigation report, BRE's investigation report, that clearly show what someone who understands the way GRP burns would expect. You see, so GRP is glass reinforced polymer, glass fibers that are placed inside a polymer matrix. I think polyester probably would be typical for this era. And when they burn, the polyester burns off and the glass fibers remain. And you end up with stringy glass fibers. You end up with a mess of a tangle of glass fibers that is what was pre-existing inside the resin before the polymer burned off. And in the photos after Knowsley, you see it. You see glass fibers hanging all over the place. You see partially burned rain screen cladding panels. It's abundantly clear what has happened. The polyester resin, assuming it was polyester, the polymer resin, has burned away and has left the fibers. And there's ample evidence of exactly what occurred. So the rain screen panels at Knowsley Heights did burn. There's no question.
But people didn't really pick it up. Is that what you're
That's
saying?
what it appears, yeah. As I say, for me, when I realized they were GRP panels and I went back and looked at the photos and realized what I was looking at, having had in my head all these years that the problem that Knowsley had a non-combustible rain screen, and the problem was the absence of cavity barriers. It was one of those moments where I just thought, I said, what? Like, this cannot be the truth. It's absolutely clear to me that the fact that the rain screen at Knowsley Heights was GRP, it was one of, if not the reason why that fire spread.
Mr. Chairman, one more question before the break, if I may. In your experience and knowledge of GRP, does it or did it routinely achieve a Class 0 classification?
I couldn't say. One of the things that's interesting about, and I couldn't say because it depends on the type of polymer, what fillers or fire retardants you might have in the polymer, the ratio between fibers and polymer. There's all sorts of reasons why it's quite difficult to say whether something would or would not. What's interesting about the Knowsley panels is that they were GRP panels, but they had an aggregate outer surface, as is mentioned in the reporting. So they had little stones that were kind of, I guess, pressed in or formed into the outer surface to make it look like it was a render or a rough cast kind of finish to the outside of the building. And I can imagine that if the rain screen product at Knowsley were tested in BS 476 Part 6 and Part 7, that the presence of that rough cast stone finish would assist the product to achieve potentially Class 0. What's interesting is that after Knowsley, one of the changes that was made quietly to the guidance was that rain screen panels need to achieve Class 0 on both the outside and inside faces. And so I believe that it's plausible that the reason that change was made is because somebody realized but did not say that the rain screen panels at Knowsley were not Class 0 inside the cavity, and that's one of the reasons why the fire spread so quickly. But that's conjecture on my part.
Yes, thank you.
Is that a good point?
Yes, Mr. Chairman, thank you.
Good. We'll have the afternoon break at this point then, Professor Bisby. We'll come back at 25 to 4, please, and usual rules apply.
Thank you.
All right. Thank you very much. Thank you very much, Mr. Millett. 25 to 4, please. Thank you. Would you ask Professor Bisby to come back in, please? Very good. Right, ready to carry on?
Yes, thank you.
Thank you very much. Yes, Mr.
Yes,
Phillips.
thank you very much, Mr. Chairman. Professor, in the exchanges before the break, you said that there were two moments in your work for the inquiry which left you speechless, and you explained what one of them was. I'm afraid that during the break, the press of curiosity has become too much for us. What was the other?
The other was when I discovered what had been tested in the CC 1924 project in the early 2000s.
Right.
Yeah.
Somebody behind me has just won a bet.
Ah, okay. Congratulations.
Now, in relation to Knowsley, if we go please to page 100, paragraph 500, you say there that Knowsley Heights was a pilot scheme for the Estates Action Programme, wherein government investment was intended to support local improvements. It was a pilot scheme for new overcladding technologies that had been the subject of BRE review. It was a pilot scheme for the fire safety of such systems as informed by BRE's earlier large-scale fire testing programme. It was also to some extent a pilot scheme for the new building regulatory system, whereby new technologies could be deployed without meeting specific performance standards via alternative routes, rather than by strict compliance with approved document B. Are you able to tell us from your review of the history and the documents relating to it whether there may have been some other reason for the investigation into the classification of GRP not being picked up as a feature?
Of the Knowsley investigation?
The Knowsley investigation.
I mean, I've tried quite hard to think of an alternative reason other than what we might call the potential for embarrassment or the self-interest of the parties involved in that scheme in one way or another. I've not been able to come up with one that I consider plausible. It may be the case that Penny Morgan, who, my understanding of her background is that she didn't necessarily come from fire science or even a physics or engineering background, that she may not have understood what she was looking at. But I mean, other people who were within the organization of BRE at that stage, these were the top fire scientists in the country. If any of these people looked at this evidence, I can't see how they would not see what I saw the moment I looked at it. So I'm at a bit of a loss to explain it, other than, I mean, the statements I've made here, and there's also, obviously, Graham Spinardi, who works in my team, went to the archives at Kew and started looking at some of the files at Kew and uncovered, this memo that the inquiry has seen.
Yes.
That alludes to certainly the potential for some embarrassment, in my view, around the fire at Knowsley Heights.
Was GRP, whether Cape Stenny or otherwise, in wide use at the time, the late 1980s, early 1990s?
That will have been a period when GRP was, I mean, certainly in that period, people were using GRP on buildings for, it's a modern material, a space-age material, and people were using it for cladding panels and various other things at that time. Yes, certainly there are a number of buildings in London that were clad with GRP that didn't age particularly well over the years.
Moving on then to a little bit later in the decade, 1994, Raymond Connolly. Can we go, please, to page 109 of your report? And at paragraph 568, you address the full-scale fire test research which was carried out and as a result of the fire at Knowsley by the BRE through Dr. Raymond Connolly, which led, I think, to a report from him in 1994 about which the panel has heard some evidence.
That's right.
During the course of this module. Now, is it right that you consider that the primary focus of that research work, which included 10 full-scale tests, was on cavity barriers?
It appeared to be interested primarily in cavity barriers, yes, on reading it.
And at paragraph 569, you observe, and I'm summarising, that one of the tests, namely test 2, carried out on a system incorporating Class 0 GRP rain screen cladding, appeared to be an almost exact reconstruction of the cladding system used at Knowsley.
Certainly very similar, yeah.
Yes. And what observations recorded from that particular test do you consider to be significant?
From the test 2.
From test 2, yes.
From memory, I mean, that test 2 escalated quite rapidly and went off the top of the rig. It behaved in much the same way that one would have expected, given what had occurred at Knowsley.
And you go on to say at 572 that, this is Connolly, the reaction to fire properties of the sheeting materials, i.e. that the rain screen sheeting was class 0 on both faces, do not give a true indication of the potential fire hazard. Mm-hmm. Yes?
Yeah, that's Connolly being quite clear. Yep.
Yes, and then at 350 there's a footnote. You conclude, and I'll read it aloud, thus by at least as early as 1994, BRE and the Construction Sponsorship Directorate of the then Department of the Environment, DOE, should have been aware that Class 0 did not give a true indication of the potential fire hazard of a rain screen product, and that this fact could contribute to a cladding system experiencing unlimited vertical spread of fire over the full height of a cladding system.
That's right, yep.
Are you aware of anything done within government at the time, from your reading of all the material, about that?
No, I mean, other than potentially, the requirements on cavity barriers being enhanced. It's conceivable that those involved felt that implementing a greater requirement for cavity barriers would address the problems. I don't know what basis they would have had for that belief, but it's possible that they held it.
Focusing on Dr. Connolly's conclusions at paragraph 572, which I've just read to you, how significant was that conclusion?
I think it's a hugely significant conclusion. Yeah.
And you go on to say that Dr. Connolly concluded that it was necessary to consider the system as a whole, and that there was still a need for full-scale testing to determine appropriate cavity protection. I'm summarising your paragraphs 576 to 577. Is it fair to say, Professor, that the focus on cavity barriers and protection reflects the report as a whole, Dr. Connolly's work as a whole?
That he was focused on cavity barriers? Yes. Yeah, I mean, the kind of, what I'm left with when I look at that work in the context of Knowsley Heights and some of the reputational issues around it, is this idea that that cavity barriers could be a way to address either wholly or in part the poor performance that had been observed. Yes.
And the focus was on cavity barriers and protection rather than the risks presented by using what appeared to be Class 0 rain screen material.
Yes. What is surprising is that it doesn't appear that anybody said, well, hang on, maybe we just should not use combustible rain screens. Maybe we should find some other way to restrict the reaction to fire behavior of rain screen products. Maybe in addition to Class 0, we should have some other requirement, or maybe we should develop a bespoke requirement that is applicable to rain screen systems and how they might behave in a fire scenario. But it doesn't appear that anyone did that, other than to argue that a BS 8414 test, what would eventually become the BS 8414 test, that a large-scale test was needed. So it doesn't appear that anybody thought, let's think about restricting the combustibility of rain screens. Let's instead think about ways we can satisfy ourselves by other means or other assessment techniques that we can still use these products in ways that would be adequate as far as we're concerned. And there is a kind of a narrative that flows through this from Knowsley Heights all the way through to the parliamentary inquiry and subsequent, that the way that what is needed is a large-scale test, rather than what is needed is some further restriction on the combustibility or the extent to which rain screen products might contribute to a fire. Yeah, there were two paths or two lines of thought that could have been followed, and the one that was followed, uniquely, was the large-scale testing path.
Yes, let's see if I can just tease out a little bit more on that. Can we go, please, to page 111 of your report? and look at paragraphs 580 to 581, you say in 580, Connolly's approach appears to have been as follows. Given that ADB allows Class 0 rain screens, and given that Class 0 does not fully address the fire hazards associated with Class 0, yet combustible rain screens, what mitigations should be introduced in order to reduce the hazards to acceptable levels? The question of whether a Class 0 rain screen is appropriate does not appear to have been asked, or if it was asked, this was not articulated or investigated. I consider the Knowsley Heights fire, its investigation, and Connolly's subsequent research to represent significant missed opportunities to explicitly address the potential hazards associated with combustible Class 0 rain screen products. Now, do you consider the fact that whether a Class 0 rain screen was or is appropriate should have been asked or investigated at that point?
Yes.
Notwithstanding that was not the focus of the Connolly report, is it your opinion, Professor, that the experiments identified significant potential hazards associated with the use of a Class 0 product?
Yes.
And had Connolly been asked to consider the question, do you consider that he would have been justified in concluding, based on his tests, that Class 0 was not a suitable measure for assessing the hazard posed by an external cladding system with a view to satisfying functional requirement B4?
Yeah, I mean, I think he says as much in his report, yes.
Is there a scientific justification for not asking Dr. Connolly to investigate that question?
I mean, I would have asked the question, is all I can say. I would have expected anyone in the room, so to speak, to have a discussion about that question. Maybe they did. I don't know. Maybe they did have that discussion. Maybe they talked it over and they decided, well, no, instead what we're going to do, because we can't come up with an alternative approach here that's based on small scale or medium scale tests. And we don't want to restrict the industry. We don't want all of a sudden there to be this problem of all these rain screen products that are being used to reclad high-rise tower blocks. We don't want to create a problem. So we're going to really push hard for a full-scale test as an alternative, and we're going to get rid of Class 0, and we're going to do it with a large-scale test. It seems that is what was being argued for in those years between this and the parliamentary inquiry, the 1999 inquiry. That the goal was to supplant or replace Class 0 with a large-scale fire test that would be used for all products and systems. Now, obviously, that's not what happened as it happens, but I see your question. I would have wanted to ask that question about Class 0 quite carefully, because the thing that's important to recognize about Class 0 that seems to get a bit lost in the conversation is that Class 0 covers all manner of products with all manner of particular hazards associated with them. You know, whether they are composite products, what types of metal faces they have, how thick those faces are, whether the cores are foamed or solid polymers or metallic honeycombs with adhesives or whatever, whether the faces are metallic or cementitious, come to that. So the problem with Class 0 is that it just simply cannot address the responses of the full range of products that it was being applied to. And a view may have been taken that a large-scale test could do that, and therefore a switch to a large-scale test may be appropriate. Now
let's look to see how Dr. Connolly describes the approach. Can we go, please, to his statement at BRE 3047667? There's his first page, and if we go to page 12, please, and I'm afraid there aren't paragraph numbers on this page, but let's pick it up at the top. He says at F, as outlined previously, test number 2 confirmed that the guidance in approved document B relying on Class 0 as a sufficient measure of fire performance was inadequate unless also associated with the guidance requiring provision of cavity barriers, which were problematic for reasons of dampness control. Rather than raising a concern, test number 2 validated the need for a full-scale fire test to allow for an examination of an integrated external wall system rather than an individual component-by-component based specification. As an alternative outcome, had Class 0 rated materials exhibited sufficiently robust fire performance at full scale, then the need for cavity barriers and or full-scale testing would not have been necessary. In this context, I would respectfully suggest that the BRE research programme was significant. With the benefit of hindsight, it is recognised that a component-by-component specification would have been an alternative and valid approach to have adopted, subject to that specification being entirely one of non-combustible materials. Such an option was never thought of by me at the time as being necessary, and I never heard any other person involved in the research suggesting at the time that such an approach was potentially necessary. Now, it looks from that Dr. Connolly considered that the tests confirmed the need for a full-scale test and that small-scale component testing would only have been a valid alternative approach if comprised of entirely non-combustible materials or products. Do you agree with that?
No, I don't. I mean, another way of reading the result of test number 2 is that test number 2 is telling you, don't use these rain screens. And it's telling you that pretty forcefully, actually.
And what does that tell you about what test?
Well, it means you don't necessarily need it. I mean, there's this weird, there's this strange kind of sort of one-way set of blinders that people appeared to have on in this period, where when something went badly, what it was showing was the need for a full-scale test, as opposed to it was showing that you shouldn't use that product. So there's in all of the narrative throughout this period, there's this strange kind of single-mindedness pushing towards this idea that the way to solve this problem is with a large-scale fire test. You'll have to remind me. It escapes me at the moment. But was there a test number 2 that was performed but with cavity barriers? I can't remember off the top of my head.
I don't believe so.
Okay, but from memory, there were a number of tests that involved cavity barriers, and many of those were deemed inadequate as well in this study. So, you know, what Dr. Connolly seems to be saying here is that test number 2 confirms that we need a large-scale fire test, and if we do a large-scale fire test, but it incorporates cavity barriers, then there seems to be this presumption that everything would be fine. But having not performed that test, I don't think, I'm not sure on what basis he's arguing that that's the case.
But this wouldn't it treat small-scale tests and large-scale tests as functional equivalents?
In what respect? I'm not sure I follow.
In the sense that they would both arrive at the same point, namely that you could use this particular product or material if you passed or didn't fail.
Yeah, if you're going to stick with class naught, yes.
Yes.
Yeah, if you're going to stick. But I mean, my argument is that they shouldn't have stuck with class naught. They should have done something different, or at least thought very hard about doing something different.
Now, he says it's with the benefit of hindsight that a component-by-component specification with non-combustible materials would have been an alternative and valid approach. But what was it that the scientists like Dr. Connolly did not know in 1994 that they came to know later so as to be able to invoke the wisdom of hindsight as he does?
I would disagree with that statement. I don't think you need the benefit of hindsight to make that statement.
And is it fair to say that, in fact, no hindsight was needed, given what the Knowsley Heights fire demonstrated about what Class 0 panels could do in the event of an external fire?
Presuming that Dr. Connolly had been briefed on what had occurred at Knowsley, yes, I would agree with that.
If we go back to your report then at page 40, please, paragraphs 195 to 197, you say there, in 197, one approach would have been to revisit the reference scenario and redevelop new model tests. And just pausing there, is that a reference to Class 0?
Yep.
Yeah. A new, more appropriate reference scenario could have been defined and a possibly voluminous and costly underpinning research conducted to determine if it was possible to link the results of a new small-scale and hopefully reproducible product test to the results in a larger reference scenario. Indeed, it may have been possible, with sufficient underpinning research, to more credibly link the existing model tests to reference scenarios involving external fire spread. This is not the course of action that was taken. The alternative approach was to prioritise representativeness over reproducibility and to create a more realistic test. The second route was one suggested by Connolly, who was apparently keen, possibly for both technical and commercial reasons, to create a test that included cavity protection, insulation and external rain screens. Connolly therefore proposed the creation of an external fire spread system test. Was that the work of revisiting the reference scenario and developing new model tests ever carried out?
Not that I'm aware of, no.
Was it your view that it ought to have been carried out?
It ought to have been very seriously considered, and I would have expected that consideration to have been, written down and documented somewhere.
And given what happened, what is your opinion of the appropriateness of continuing to use Class 0, developed as it was for an internal reference scenario, in the context of assessing the safety of external cladding systems?
It should not have been. It should have been reconsidered. It should have been reconsidered immediately after the Knowsley fire.
And if we go to page 253, paragraph 1578 to 1580, I won't read it all out to you, just remind you what you said there. Under the summary, 1578, 1579 and 1580, you summarise your views there. Just on the basis of what you say there, is it your view that the continued use of Class 0 in the context of the safety of external cladding systems represented a hazard to life safety?
Yes.
Do you consider that the focus on mitigation obscured the extent to which the continued use of Class 0 was a hazard?
Yes.
And what ought to have changed after Knowsley and Connolly, given what they showed?
What ought to have changed? The machine of government regulation, BRE, the relevant government departments, should have removed Class 0 as the means by which cladding products could be assessed and accepted for use on the outside of buildings. They should have thought about the products that were being used across the industry, how those products react when exposed to heating, and what that means for the performance with respect to external fire spread. Now, they might claim that that's what the BS 8414 test was trying to do, and that had the BS 8414 test been implemented as an alternative to Class 0 rather than as a parallel stream or parallel approach to Class 0, that it would have addressed those issues, and maybe it would have. It's hard to say with hindsight. If you test ACMP on an 8414 test, notwithstanding all my comments about complexity and differences in behavior, I defy you to pass that test.
Let's turn to Garnet Court,
Sure.
1999. 11th of June in that year, 14-storey block of flats in Irvine in Scotland overclad as part of a refurbishment. Again, GRP, yes?
Yes.
And if we go to page 123 of your report, paragraphs 634 and 635, under the heading Garnet 1999, you say, you describe the fire in paragraph 634, and then in 635 you say, as had been the case at Knowsley Heights, Garnet Court had been reclad using a GRP cladding product. However, in this case, the GRP was installed over a more localised portion of the building, essentially as preformed spandrel panels installed below the living room windows, along isolated vertical lines up the sides of the building. Figure 15. At Garnet Court, however, the refurbishment GRP cladding was not a ventilated rain screen, and the cladding system therefore also did not need to incorporate cavity barriers. Now, it's right to think that, as with the fire at Knowsley Heights, the Garnet Court fire was investigated by the BRE on behalf of central government.
Yes.
This time, the Department of the Environment, Transport and the Regions, as I think it had become. Yes?
Mm-hmm. Yes.
And it was reported as part of the August 2000 investigation of real fires report done by the BRE under contract with the government. Yes?
Yep.
and also the subject of reports prepared by the BRE for the Procurator Fiscal's Office and for Irving Council, both in Scotland, yes?
That's my understanding. Yep,
Yeah. And you've read those reports, yes?
I have.
If you go, please, to 637, just in the middle of your screen, you say the fire investigation report issued by BRE to DETR in August 2000 described Knowsley Heights refurbishment GRP cladding in considerable detail as follows, and then you set all that out. And then you say a couple of paragraphs on, at 639, the only substantive technical commentary on the role of the cladding in the fire spread at Garnock Court is contained in the following passage. And then you say this at 640. The video from Tesco's security camera shows full involvement 15 minutes after the call to the brigade and for the next 7 minutes. The video shows even burning up the external surface of the GRP with the production of flames and dense black smoke. This indicates the involvement of the GRP alone rather than the contents of the flats, as the burning pattern would vary according to the materials burning. Is it fair to say that the report into the Garnock Court fire contains less detail as to the nature of the GRP cladding than the Knowsley Heights report?
Contains less detail. I would say it contains probably a bit more.
A bit more detail.
Yeah.
It
at least makes it clear what we're dealing with.
Right. You say at 641, it's clear from the above descriptions that the presence of the combustible GRP spandrel panels was the primary contributor to the rate and extent of external vertical fire spread at Garnock Court. The video has unfortunately not been made available to me. Are you able to tell us how you reached that conclusion? That the GRP spandrel panels were the primary contributor to the rate and extent of the external fire spread at Garnock?
I mean, largely based on the information that's given in the BRE's report. The only thing on the outside of the building that's combustible is these GRP panels. These are preformed GRP spandrel panels, essentially. I imagine they're quite polymer rich at their surface, and I can imagine that they would burn pretty enthusiastically, based on my knowledge of GRP.
Now you go on to say at paragraphs 642 and 643, the foot of page 124 and over to page 125, and I'm summarising, that no further testing on the spandrel panels and no explicit comment was made in the DETR report as to whether the panels were class 0 or whether there were any implications for the building regulations in England. You say you consider that surprising. Have you seen any evidence in the form of a document or a witness statement that would provide what you might consider to be a tenable explanation for those omissions?
No.
If we go to page 133, then, paragraph 701, you observe that testing on the spandrel panels was carried out between August 1999 and May 2000 under confidential contract to North Ayrshire Council. Yes? Mm-hmm. So some testing was done?
Later.
Yeah. But not by central government, only under contract to the local council?
That's right. I believe that work was done on behalf of the local council and in some way in association with the Procurator Fiscal.
Yeah. Can we go to the next page 134, paragraph 703? And you say there, as part of my work for the Grenfell Tower Inquiry, I performed a side-by-side comparison of the reports prepared by BRE for North Ayrshire Council and the report prepared by BRE for Department of Energy, Transport and the Regions. The reports for North Ayrshire Council, dated August 1999 and April 2000, were prepared by Penny Morgan, Brian Martin and Tony Morris. The report for DETR was submitted to Anthony Bird as part of the August 2000 investigation of real fires report and was prepared by Penny Morgan. I've noted what I consider to be some potentially significant differences, and you've done that. Now, you then go on to say at 705, in the last line, or last sentence, the removal of mentions of Class 0 from the reports to DETR appears to have been performed intentionally. Now, you opine there that the removal of mention, or the omission of a mention of Class 0 was intentional. To be clear, are you offering no more than a lay view of the evidence, as opposed to your expert opinion?
If you perform, I suppose so. If you perform a side-by-side comparison of the two reports, what's striking is that they are, in the relevant sections, verbatim, or almost verbatim. And yet, the sentence that deals with class naught, or the specific set of words that deals with class naught, has been removed from the reporting to government, but is present in the North Ayrshire reporting. I suppose that's a lay assessment. What is interesting to me, or what I'm puzzled by, is why that information is considered sufficiently uninteresting to government that it should be explicitly removed from text which is otherwise verbatim.
What is the significance of the omission of the mention of class naught in the report that went to government?
That it by its omission does not flag the issue of class naught. It appears to not want to draw attention to class naught. That's all I can really say about it. I have, I've watched obviously much of the testimony that's been given in Module 6, and I recognize a number of the witnesses were kind of questioned about this discrepancy, and none of the witnesses were able to give a very suitable rationale for why that discrepancy existed, which I think is also a bit puzzling. The only explanation that I have been able to come up with is that in the reporting to government, which I think occurred, the reporting to North Ayrshire Council, that was, I believe, temporarily earlier than the reporting to government where those relevant sections of text are included. And it may be that in the intervening time period, certain decisions had been taken and certain replacement products have been installed that meant that the mention of class naught was not necessary anymore. But it is striking by its absence from any of the reporting to government, in my view.
Now, we come on then to the Select Committee recommendations and the government's response. There's another missed opportunity in your list, I think. I'm not going to ask you any questions about the evidence given or whether you agree or disagree with the recommendations. But if we look at the recommendations themselves, you summarise those on page 133. If we can go back to that, please, at paragraph 697. And we can see that there. In the middle of the paragraph, you record as follows. Thus, they suggested that the new BRE test, i.e. the test described in Fire Note 9, which would later become BS 8414, should be reissued as a British standard and be substituted in the proof document B to replace previous recommendations relating to the fire safety of external cladding systems, i.e. that class naught should no longer be used in this context. And I think we can agree that that recommendation was not subsequently acted upon as a fact. But you then go on at 720 in paragraph 720 on page 137, if we go to that, please, to note that class naught wasn't even mentioned within the government's response to the first report of the 1999 Select Committee inquiry. Is that the Nick Rainsford response of the 6th of April?
I believe so. I'd have to check the reference somewhere on that page. Yeah, I see that.
Right.
I think so, yes.
Yes. In your view, was the failure to implement the Select... Well, let me put it neutrally, perhaps. How would you characterise the failure by government to implement the Select Committee's recommendations?
How would I characterise it? Foolish? Irresponsible?
A missed opportunity?
A missed opportunity, for sure.
And I want then to ask you finally on Garnet what we should have learnt from it. And can we start with that question, with page 138, the following page, paragraph 726. And you say this: given that Garnet Court's GRP overcladding fell significantly short of meeting the recommendations for class naught, and hence did not even comply with the recommendations of approved document B at the time of Garnet Court's overcladding refurbishment, the key issue at Garnet Court was actually one of inadequate adherence to the existing guidance, rather than the existing guidance necessarily being inadequate. It is not clear what steps were subsequently taken by government, if any, to enhance oversight of adherence to building regulations, guidance, or to verify that similar oversight had not occurred on other buildings across Britain. Does it follow that, in your view, there was nothing about the circumstances of the Garnet Court fire that suggested that a large-scale test was required?
The Garnet Court fire itself, that's right. Yeah, I would agree with that statement. The Garnet Court fire showed that someone had put something on the outside of a building that you should not put on the outside of a building, and that everyone knew you shouldn't put on the outside of a building.
Right. So it was the lesson from Garnet, not that there was something wrong with Class 0 per se, but there was something wrong with adherence and enforcement of the regulatory system as it stood.
And or the competence of those people who were doing that type of work, yes.
Right. And you say at paragraph 727, rather than eliminating the use of Class 0 for external cladding products, or alternatively more tightly restricting its application to products where the testing methods underpinning a Class 0 classification were more technically credible, the government chose to simply add a new and potentially lucrative to the recently privatised BRE alternative route to demonstrating compliance with the recommendations of the approved document B, i.e. large-scale fire testing to BS 8414. Now, standing back and on a full and fair view of what transpired at Garnet Court, namely, as you say, inadequate adherence to the guidance rather than inadequate guidance itself, was elimination of Class 0 justified?
Not on the basis of Garnet Court, but on the basis of evidence that was heard during the Select Committee inquiry. I think certainly some pretty deep thought about reconsidering Class 0 would have been appropriate. The evidence given by Dr. Bob Moore, for instance, a number of comments made by various people who gave evidence in that inquiry, who were highlighting concerns around Class 0, concerns around the use of small-scale tests for a variety of reasons. That's the basis upon which I think there was a missed opportunity. It's not that Garnet Court. What's interesting about Garnet Court is that a fire that happened for quite a straightforward and obvious reason precipitated a Select Committee inquiry that then ended up asking the really important questions that were unrelated to the fire that had initiated the inquiry, but nonetheless were questions that had been asked and demanded some response, in my view.
Yes, thank you. And is it your view that introducing large-scale fire testing as an alternative, as a choice, as an alternative way of demonstrating compliance with the functional requirement was not an appropriate response?
Yeah, I think that's true. I think it actually made matters worse.
Why worse?
Because it introduced, another way that people who couldn't get through the Class 0 route might be able to get through. It opened up opportunities for people to attempt to game the regulatory system, which otherwise wouldn't have existed. If all you have is Class 0 to try to game, then certain products would just never be able to do it. But if you have large-scale testing as well, then other products might be able to get through the alternative route.
And we'll see that shortly, perhaps with the introduction of the Euroclass regime and the work done around that. Let's go to that then. You've explained a little bit about the European SBI, single burning item test. We know that in 2000, a decision of the European Commission led to the adoption across Europe of the European Reaction to Fire System, EN 13501, Part 1, to harmonise methods of classification. And you've covered that in your report at paragraph 600. Am I right in thinking that EN 13501 is a composite classification system?
That's correct. Yeah, it depends on a number of tests.
There's a number of tests, and the single burning item test, which is EN 13823, is one of a number of tests used to classify products or materials under the Euroclass system.
That's right.
And you tell us in your report that although the British standard test methods used to establish national Class 0, which is 476 parts 6 and 7, and the SBI test are very different tests, they are nonetheless strongly allied or aligned, perhaps conceptually. Yeah, is that correct?
Yes, they are both model tests, and they're both Part 6 and 7 as separate tests, and SBI as a single test, notionally based around a reference scenario of a fire growing in the corner of a room, as we discussed earlier. Yeah.
Yes. And in terms of the alignment you refer to, both sets are focused, as you say, I think, on a fire in an internal reference scenario. Can you describe what the differences between the tests are?
Other than by explaining what the tests are, not really. I mean, if you look at the S476 Part 6 test, you have a little plate of material in a little box, and you heat it and you measure how much heat comes off it, essentially. In the Part 7 test, you have the lateral flame spread, so you've just got a flat sample, and you have a heat flux exposure that decreases as you move along the sample, and you ignite a fire at one end, and you see how far the fire goes. Quite straightforward. The SBI test is a more complex test. Is a model that looks more like, if you like, the model that it's intending to simulate, and captures and kind of mixes a lot of the physics that would be more separately interrogated in Part 6 and 7. So, Part 6 is about how much heat is coming off or out of a product. Part 7 is about flame spread across a product. SBI is doing both of those things and others in a single test method.
And what is the significance of the differences?
The significance of the differences between 476 Part 6.7 versus SBI?
Yes.
I mean, they're very different. They're very different test methods. They're measuring similar things in different ways. I mean, one good example would be that the SBI test uses oxygen consumption calorimetry to measure heat release rates, to calculate the various limits that define the class limits in the Euroclass system. The Part 6 test measures temperatures and uses the measurement of temperature as a proxy for energy release rather than measuring energy release directly. So there's a whole host of differences that again are relevant to how one uses the outcomes or thinks about using the outcomes in a real world application.
Dr. Smith, Debbie Smith of the BRE, told us that there were completely different tests, like comparing an apple with an orange. Both items are fruit, but they are different. That's what she told us at day 235, page 185, lines 7 to 13. Would you agree with that characterization?
I could go along with that. Yes, both fruit, but different fruits, sure.
Right.
Yep.
Let's then turn to composite panels with combustible cores. Is this right, that there were concerns in 2000 when harmonisation was being considered about the adequacy of the SBI test adequately to reflect the fire hazards presented by metal-faced polymer-filled core panels?
There were I wouldn't be able to date the concerns, I don't think, but there certainly were concerns during the development of the SBI and subsequently that the SBI did not do a good job of predicting the outcomes of the scenario tests upon which it was calibrated. So the SBI did not do a very good job of assessing the fire hazards associated with metal-faced foam core panels, for instance, sandwich panels. Yes.
Right. Let's look at page 116 and see if we can pin this down. On page 116, there is paragraphs 607 and 608. At 607, you say this: as already noted in Part 1, despite the SBI's implementation via the European Directive of 2000, there was disquiet in some quarters because it could not easily classify some products. EN 13501 Part 1 classification of, quotes, exotic, unquotes, composite panels with combustible cores and external metal skins was felt by some to be dangerously misleading. And you have footnote 386 there, which is a reference to Messerschmitt 2008. Now, is that a quotation of what Birgit Messerschmitt said in 2008?
Use of the word exotic is a quotation, yes, and I mean, that's probably a paraphrase of what she will have said. Yep.
Right.
So the 2008 reference is to an event that was actually held in Edinburgh shortly after I moved to the University of Edinburgh, and Messerschmitt gave a talk at a conference that had been organised by the University of Edinburgh. And she set out her concerns as someone who had been involved in the process of developing the SBI test through the preceding decades.
I mean, can you recall whether her views were well respected and shared commonly, or was she regarded as perhaps something of a Cassandra?
No. I mean, I certainly respected her, and I think everybody in the room respected her. Whether that's representative sample of the community is hard to say. The only caveat that is probably worth mentioning is that at the time, Brigitte Messerschmidt was working for Rockwell, who are a mineral fiber manufacturer, and the products that the SBI did not well predict were polymer foam core products, so products that will likely have been manufactured by her competitors. But I think she would have been totally open about that. I don't think she was trying to hide that fact from anyone.
Are you able to shed any light on, first, whether the Birgit Messerschmidt views, if I can put it that way, as you described it here, were any part of the British mainstream in the early noughties and beyond?
I think there was a recognition in some parts of the community that metal-faced sandwich panels in particular had the potential to cause significant problems in real fires, but from a regulatory perspective were able to achieve classifications that were perhaps more positive than they might deserve when faced with the reality of fires, if that's a diplomatic way of putting it.
It's diplomatic to the point, perhaps, of inviting a further question. Which parts of which community?
Well, so for instance, colleagues at Edinburgh in the years after 2008 were involved in a research project where metal-faced foam cord panels were tested in room corner tests, so tests with boxes made of room-sized boxes made of metal-faced sandwich panels. Those sandwich panels were very slightly damaged, with a small hole or something in the metal skin, and the outcomes of those tests were not good. So it didn't take much of a chink in the armor of the metal-faced sandwich panel to demonstrate very poor fire behavior. And one can argue, as was argued by the manufacturers of those products at the time, that that was not a fair thing to do, because the regulatory tests that were giving them their very nice ratings said that they were okay, and these tests seem to indicate that they weren't. So this is the problem. It's the fundamental problem when you set up an unthinking, incompetent regulatory system, is that people will make those arguments and they will succeed. They will hide behind a test that allows them to do something that everyone knows they shouldn't.
Mr. Chairman.
Yes.
I've come to the end of part of this topic, but I'm reluctant to start on the next one, which is the final element of the harmonisation regime, which is quite long, and we will not finish before 4:30.
And would it be better to finish there?
It would be better to finish there. I'm confident that we will finish Professor Bisby's evidence at some stage during the morning of Wednesday,
right,
given that we're not sitting tomorrow.
Thank you. Well, Professor Bisby, it's a little earlier than usual, but it sounds like it would be a sensible point at which to stop. And I think you were already arranging to come back on Wednesday, were you not?
Yes.
So it sounds from what Mr. Millett is saying that you'll be away, should we say, by lunchtime, or can hope to be away by lunchtime. You never quite be sure of these things.
Yeah.
All right, so we'll break there, and we'll look forward to seeing you again on Wednesday. We're not sitting tomorrow, as you know. And I think it's probably right that I should remind you not to talk to anyone about your evidence or anything relating to it over the breaks. It's
Certainly
a long one.
Sure.
All right, and we'll look forward to seeing you again on Wednesday, 10 o'clock Wednesday morning.
Thank you.
Thank you very much. Well, thank you, Mr. Millett. As I indicated a moment ago, we shall not be sitting tomorrow in recognition of the fact that tomorrow is the 5th anniversary of the fire. So we shall resume our hearings on Wednesday morning at 10 o'clock, and when Professor Bisby will be back to answer some more questions.
Yes. Mr. Chairman, thank you very much.
Good.
Thank you.
Thank you very much. 10 o'clock on Wednesday, please.